Unit 1. Periodicity of elements and their properties. Lesson 1. Attempts of elements classification. Classification of elements. Give reasons for. Scientists thought about classifying elements according to their properties. In order to, number 1, facilitate their study. Number 2, to find a relationship between elements and their chemical and physical properties. The most important attempts that we will study in this lesson are Mendeleev's periodic table, Moseley's periodic table, and finally modern periodic table. We will start with Mendeleev's periodic table. Mendeleev did the following. Mendeleev prepared 67 cards. Each card represents an element. He recorded the name of each element on each card with its atomic weight and its important properties such as boiling point, degree of fusion, and density. He arranged elements of similar properties in vertical columns, which were known later as groups. After this arrangement, Mendeleev discovered the following. As you can see, Mendeleev discovered that the atomic weights of elements increases, but in a non-uniform way, on moving from the left side of the table to the right side in the horizontal rows, which were known later as periods. As you can see, the atomic weights of element increases as we go from left to right, but in non-uniform way. Also, Mendeleev discovered that the properties of elements were repeated periodically by the beginning of each new period. We will study advantages of Mendeleev's periodic table. The first one is that Mendeleev left gaps or empty space or empty cells in his table. And this is an important give reason question. This is because he predicted the discovery of new elements. Mendeleev said that these spaces will be filled in the future with new undiscovered elements. So Mendeleev left gaps predicting the discovery of new elements. The second advantage is Mendeleev calculated the values of atomic weights of some elements which were not discovered yet. Mendeleev not only left gaps, but also he calculated the atomic weights of the elements that will be discovered in the future. The third one is that Mendeleev corrected the atomic weights of some elements which were estimated wrongly, such as beryllium, gold, platinum, and so on. Now we will talk about disadvantages of Mendeleev's periodic table. The first one is that Mendeleev had to make disorder. As you can see, here the atomic weight of element which is called Ta is 181, for the second one is 184, for the next one is 180, then 194. As you can see, we said that atomic weight increases as we go from left to right, but here we have one element which is not in the correct order. So Mendeleev had to make this order in the arrangement, in the ascending order of atomic weights of some elements. And this is an important give reason question also. This is done by Mendeleev to put them in groups that suit their properties. The second disadvantages is Mendeleev had to consider the isotopes of one element are different elements. Why? Due to the difference in their atomic weights. So he had to put more than one element, as we can see here in each cell from these cells. Each cell contains two elements. But what's meant by isotopes? Isotopes, they are atoms of the same element which have the same atomic number. As you can see here, they are all hydrogen and their atomic number is 1. But they differ in their number of neutrons. So their mass number differ from one isotope to another because they have different number of neutrons. Now let's compare between advantages and disadvantages of Mendeleev's periodic table. Mendeleev left gaps or empty cells in his table, predicting the discovery of new elements. Disadvantage: he had to make disorder in the arrangement in the ascending order of atomic weights of some elements to put them in groups that suit their properties. Advantages: he determined the values of atomic weights of some elements which were not discovered yet. The final disadvantages: he had to consider the isotopes of one element are different elements due to the difference in their atomic weights. The final advantages is that he corrected the atomic weights of some elements which were estimated or calculated wrongly. Because Mendeleev thought that isotopes of the same element are different elements, so he had to put more than one element in the same cell or in the same place in his table. Now let's talk about the second attempt, which is done by Moseley in his table, Moseley's periodic table. The New Zealand scientist Rutherford discovered that the nucleus of the atom contains positively charged protons. This fact wasn't known before Rutherford. After doing the experiment that we see it right now, Rutherford discovered that there is a central core inside the atom. This central core is positively charged. So they contains positively charged particles which were called protons. This useful information discovered by Rutherford, and after studying X-rays, Moseley found that the periodic properties of elements are related to their atomic numbers, not to their atomic weights, as Mendeleev proposed or as Mendeleev thought. The most important modifications of Moseley on Mendeleev's table. The first thing that Moseley did is he rearranged elements in an ascending order, but in this time according to their atomic numbers, where the atomic number of each element increases by 1 from the preceding element in the same period. This is the most powerful advantages of Moseley's periodic table. We can predict the atomic numbers of elements only by knowing their position in his table, because the atomic number increases from left to right in a uniform way. He added zero group, which includes all inert or noble gases, at the end of his table in group 0. He classified the elements of each group into two subgroups, A and B. And this is an important give reason question. This is because the difference between their properties. Because each group from groups of Mendeleev contains different elements in their properties, so Moseley divided each group into two subgroups, A and B, because they were different in their properties. Moseley specified a place below his table for lanthanides and actinides. As you can see, between BA and LU there is a huge gap. The atomic number here is 56 and for LU is 71. The rest are here, LA 57 till LU 71. These group of elements are called lanthanides, and also we have the same gap between RA 88 and the LR 103. This gap is filled by this group of elements which are called actinides, start from actinium AC 89 and ends with LR 103. Bohr discovered the main energy levels of the atom, and their number reaches 7 in the heaviest known atom till now. Before Bohr, we don't know that the electrons are distributed in energy levels. The scientist who discovered that electrons are distributed in energy levels is Bohr.